Welcome, OChem 8C students. So today we're going to go over the second worksheet of week 10, and of course this will be our final worksheet. If you guys could please sign into the description box and we can get started. So for the first question, we want to first identify the repeating unit. And the easiest way to do this is to just find a pattern. So I'm just going to start counting from here, 1, 2, and then this is also a carbon, 3. But you have to keep in mind that they all have to have the same amount of carbons. So if I look at the next carbon to the right, I find that it looks just like this group right here. So when I count it 1, 2, 3, I get the same thing. But we're not fully sure because we have to keep counting and making sure that they all have the 3 carbons and follow the same pattern. So 1, 2, 3, 1, 2, 3. And I see that I'm correct, and this is the repeating unit that I highlighted in pink. Okay. So is this monomer necessary to prepare this polymer? Yes, because it is following that repeating unit. And whether this polymerization would be best achieved via cationic or anionic. So for cationic, you would need strong electron donating groups. So I'll just write that, or actually I'll write it on the next questions. And then for anionic, it would be best with electron withdrawing groups. So we see an aldehyde, right? That's the R group that's on this chain. And aldehyde, although it's not strong, it is a moderate electron withdrawing group. And for electron withdrawing groups, that's best with anionic addition. Okay, so for the next one, they're asking us to rank the following monomers in order of reactivity towards cationic polymerization. And I just want to quickly just explain the difference between monomer and polymer. So if I have a repeating chain, so let's just say it looks something like this. So this entire thing is a polymer. And the single units are monomers. So when we look at question number 1, the chain that we identified here is the monomer, whereas the entire chain, the repeating subunits of monomers, make up a polymer. Okay, so now we can move on. So for question 2, we're just ranking based on the cation polymerization. And for cation polymerization, it's best reacted with electron donating groups. So let's go through every R group that's on this 2-carbon chain. So we see that this first one is an ester, right? This is the AC stands for an acyl group, so it looks something like this. So this right here is an acyl, and the entire thing is an ester. And esters tend to be moderate electron withdrawing groups, meaning that they're not too weak but not too strong either. And also there's a list, if you guys need to brush up online, you can find them online, and they'll give you a list of strong electron withdrawing groups versus strong electron donating groups. Okay, so now we're going to look at the NO2. NO2 is a very strong electron withdrawing group. And this right here is just a methyl, and methyls are electron donating groups. So based on here, we can see that the closest to an electron donating group is the methyl, so we can rank this one. And then this is the second closest to electron donating group, so that's 2. And then the NO2, since it's so far and it's in the electron withdrawing group spectrum, this would be considered 3. Okay, now let's move on to number 3. So rank the following monomers in order of reactivity towards anionic polymerization. So this works best with electron withdrawing groups. So let's go through each and every one and label which one is a better electron withdrawing group. So this right here is ketone. And we have that ketones are moderate electron withdrawing groups. Okay? And then NO2 is a strong electron withdrawing group, as we identified in the previous example. And then halogens tend to be weak electron withdrawing groups. So just by looking at this, we can see that the strongest electron withdrawing group is the NO2. Then we have the moderate electron withdrawing groups, and then we have the weak electron withdrawing groups. So that's it for this worksheet, and if you haven't, please sign it into the description box. Thank you.